In this session, we are going to examine agglomerative clustering algorithms. We already introduced the general concepts of agglomerative and divisive clustering algorithms. Now from the computer science point of view, we can think agglomerative clustering essentially is a bottom-up clustering. That means we start from the singleton clusters. That means every single element treated as one cluster. Then we try to merge their nearest neighbor into bigger clusters and eventually merge them into one cluster. This one is a bottom-up or agglomerative clustering. Okay. In Kaufman and Russo's 1990 book, they described one algorithm they call AGNES, or agglomerative nesting. This algorithm uses a single link method, or we call nearest neighbor method, and the dissimilarity matrix try to continuously merge nodes that have the least dissimilarity, or the nearest neighbor. Eventually, all the nodes merge into one cluster. Okay, that means you start from the singleton, you try to find everyone's nearest neighbor. Then you check the closest, the nearest neighbor, you try to merge them. Okay. Then once you merge into bigger cluster, you will look at the cluster, their nearest neighbor, their single link. Then you decide which one to merge, and eventually you'll merge everything into one cluster. Actually, in the real agglomerative clustering algorithms, they vary on different similarity measures. For example, we just discussed AGNES. It uses nearest neighbor, we call single link measure. You also can use the farthest neighbor, or diameter, that's a complete link. Then you can use group average. That means you average everything based on their distance. Every pair of elements, you average them. Then you calculate the distance based on the average link. Or we can use centroid link. That means we look at the distance between the centroids of those clusters. Let's examine a little detail on these different links. We first look at the single link, or we call nearest neighbor. Okay. So the similarity, or the distance between the two clusters, is defined based on the most similar or the closest elements in these two clusters. Okay. Just to give you an example, suppose one is the US, one is Cuba. You want to find their closest points. Likely in the US, it will be the Key West. So such kind of merging essentially is you examine its neighbors or the close regions. So ignore the overall structure of the cluster. So in that context, you will be able to find irregular shape or non-elliptical shaped group of objects. This link is also sensitive to noise and outliers, because obviously if you get an outlier which is very close to the other one, you may decide to merge them. Another approach called complete link is you check the diameter of the cluster. The idea is you try to define the similarity between the two clusters based on their farthest neighbors. That means between the most dissimilar elements in these two objects. Okay. For example, if you define the distance between US and Cuba, you probably, for the complete link, you may pick up the farthest point in Alaska. So that's pretty far apart. So that means you actually try to merge the two clusters to form one with the smallest diameter, because when you merge them together, you want the finer one is pretty compact. You examine non-local behavior, you obtain compact-shaped cluster, but this method also sensitive to outliers. Okay? Because you probably do not even want to think about Alaska. You may think about Hawaii or Guam. You try to merge them. That's pretty far apart. Then we will look at the average link. The average link between two clusters actually is rather expensive to compute, because what you want to calculate is the average distance between all the elements in one cluster and all the elements in the other cluster. That means you calculate all the pairs of the two clusters. then you try to average them. For example, if you have a number of cluster in C sub A is n sub A, and a number of elements in cluster C sub B is n sub B. So what you want to calculate the distance, essentially you will get a total number of pairs is n sub A times n sub B. That's pretty big. Then you average them. So an easy way or more efficient way to calculate the distance between two clusters actually use centroid link. The centroid link means you calculate the centroid of cluster C sub A, the centroid of cluster C sub B. Then the distance between the two clusters is defined by the distance between these two centroids. And you may even want to put a weight there. For example, if the cluster C sub A has many, many points versus cluster C sub B, you want to take this into consideration. Then we introduce GAAC, or group averaged agglomerative clustering. That means if you assume the two clusters C sub A and C sub B be merged into one cluster C sub A union B, then the centroid will be defined by you get a centroid of C sub A, but you times the number of elements in the cluster. Then get a centroid of C sub B of cluster C sub B, bigger C sub B. Then you want also times their number of elements. Then you finally normalize them. Okay, so this is the GAAC measure. Another interesting one is people define one called Watts criterion. This one essentially is to measure the increase once you do this merge. Remember, once you merge the two clusters, C sub A and C sub B, into C sub A union B, the SSE, the sum of the square distance, will increase because the cluster becomes bigger. Okay. Then once it's increased, you want to see the original clustering. What's the difference? What's the increase you got on this? Okay. This one is defined using this criterion. Essentially is you look at the distance between the two centroids, and then you, based on this weight, you calculate the increase.